Assalamu alaikum guys, welcome back. Okay, so now in this video we are going to talk about ionic bonding. In the previous video we did an overview of chemical bonding. By the way, I didn't tell you what bonding actually is. Bonding is the same concept as you did in O levels. Bonding is basically a sort of connection between two atoms or molecules or ions, etc, etc. Okay, so now, or two particles. In case of metallic bonding, it's a connection between positive ions and negative ions. Okay, now let's get started. In this video we are going to talk about the ionic bonding. Okay, so I told you that all the ionic compounds that we have in our syllabus, they have a structure called the giant ionic lattice, and lattice is actually a repeating pattern of ions or molecules or atoms. Okay, for example, in case of sodium chloride, on top over there it's a pattern of sodium and chloride ions being repeated again and again. First of all, let me define what an ion actually is. Okay guys, you must know this from your O levels that ions are actually of two types. Ion is a charged species. Any species that has a charge is an ion. But now you guys are gonna ask me that are electrons also ions? Well, yeah, they are negative charges, they are not ions. Okay, ions are basically formed from atoms themselves. Okay, ion is actually a much larger species as compared to an electron. Okay, so now ions are actually of two types. There are positive ions or negative ions. The positive ones are called cations, and the negative ones are called anions. As you guys know it from your O levels, and examples of cations include all the metals, metallic elements, metallic ions. Okay, group 1 metal, sodium, potassium, and group 2 metals, calcium. Group 3 metal, aluminum. Metals mainly form positive ions. Silicon is an exception. It's a metalloid. It can form both positive as well as negative ions. Positive will have a charge of Si plus 4 and negative will have a charge of Si minus 4. The reason why it can form both the ions is because its octet is actually half filled. So it can either lose all the 4 electrons or it can gain for all the 4 electrons. How are positive ions formed? Positive ions are formed when atoms, they lose electrons. Okay, remember, they lose electrons. And negative ions are formed when they gain electrons. Okay, gain electrons. Electrons are negative charges, so if they gain electrons, then they'll have an excess of negative ions in them. And if negative charges are in an excess, then the overall charge is gonna be negative. Okay, now this is for cations and this is for anions, and I guess this was a quick revision, a recap from your O levels. And you know many ions, okay, which are negatively charged. For example, sulfate is a negatively charged ion, phosphate is a negatively charged ion, etc, etc. Now the bonding that is formed between a positive cation and a negative anion is called ionic bonding. Okay, in ionic bonding, a metallic ion or a positive ion, it loses an electron, and that same electron is gained by a non-metallic element. Okay, and as soon as that non-metallic element gains the electron, it forms an anion. As soon as the metal loses the electron, it forms a cation, and then a bond forms in between the cation and the anion, because they are of course oppositely charged, so they'll have a force of attraction. This force of attraction, I should rather say this electrostatic force of attraction. It's electrostatic. Okay, ionic bonds are electrostatic forces of attraction. This electrostatic force of attraction between a positive metal ion and a negative non-metallic ion is called ionic bonding, force of attraction. Okay, and it is formed by the transfer of electrons. So if you are asked the definition of ionic bonds, well, usually in A levels they don't ask you to define ionic bonds, but in case they do ask you to define the ionic bonds, so you have to write that ionic bonds are strong electrostatic forces of attraction which are formed as a result of transfer of electrons from a metallic cation or from a metal atom to a non-metallic atom, resulting in positive and negative charges. Okay, or you could say that these are simply strong electrostatic forces of attraction between oppositely charged ions, and that's it. Simple definition of ionic bonds. Okay, now this was an overview and of for your mainly of your O levels and stuff that you have to write on your exams. Now let's see how the you are going to represent them diagrammatically. Okay, so now let's take the example of sodium chloride. Sodium chloride. Sodium is a positively charged ion and chloride is a negatively charged ion. So sodium chloride is your giant ionic lattice of sodium chloride is in there. Okay, now in this case, if you were to draw it in a diagrammatic fashion and represent this in a diagram, the structure, so this is how you're going to do that, showing basically a dot and cross diagram. If you were to draw a dot cross diagram, a dot cross diagram is usually asked to draw, by the way, for sodium chloride in your A levels, then this is what you are supposed to do. Okay, first of all, you'll need to draw out sodium. So sodium, as you guys already know, is in group 1, so it will lose 1 electron, and that same electron will be gained by chloride because chloride is in group 7, and it will gain that electron to complete its octet, and sodium will lose the electron to form an octet around it, right? So now, sodium, the outermost electrons of sodium and chloride have to be shown in a dot cross diagram. Okay, dot cross diagram always shows only outermost electrons. Now sodium, the outermost electrons in case of sodium are gonna be crosses. I'm gonna represent the electrons of sodium by a cross and the electrons of chloride by a dot. Okay, now sodium will have 8 electrons remaining in its outer shell, right, after losing 1 electron. So these are the 8 electrons around sodium. And by the way, you don't need to draw the circles over here, okay? In A levels, it's fine to not draw the circles, but you have to show the charge. This is the charge of sodium, positive, okay? You have to put the entire species of sodium in brackets and then put a plus charge, because that's the charge it gains after losing 1 negative ion. It becomes electron deficient. And in case of chloride, chloride already had 7 electrons of its own. So I'm going to first draw the 7 electrons of its own, shown by a dot, shown by dots basically. Okay, so these are the 7 electrons of chloride, but it has gained 1 electron from sodium's outermost shell, right? So I'm going to show that electron by a cross and again put a bracket around chloride as well and put a negative sign over there. And the charges in this case are very, very important, okay? Because if you don't show the charges, then the examiner might not know what the positive and negative charges you've tried to show, right? So the charges are very super important. Basically, they usually have marks. So this is the entire structure of sodium chloride, the ionic structure, dot cross diagram of sodium chloride that you are expected to draw out. Then, what about Al2O3 if you get a species like Al2O3 in which there are 2 aluminum atoms or aluminum ions and 3 oxygen atoms? So what to do with these? So it's simple. You don't need to draw aluminum twice. I'll show you what to do. Okay, in this case, aluminum has lost 1 electron. Again, I'm going to show the cross to be the electron of aluminum and the dot to be the electron of oxygen. Now aluminum will have 8 electrons in its outermost shell after losing the 3 electrons, right? This is 1 aluminum, but this is 1 aluminum, but are there is there 1 aluminum atom in there or 2 aluminum atoms, or I should say 2 aluminum ions in there, 2 aluminum ions. So I'm going to just place a 2 in front of the aluminum, and this aluminum will have a charge of how much? It's going to have a charge of +3 because aluminum is in group 3 and it loses 3 electrons whenever it forms a cation ion. And then how many oxygen atoms do we have in here? 3. So I'm going to place a 3 in front and then make an oxygen atom. Okay, now this is oxygen. Now tell me guys, how many electrons did each oxygen atom gain? I'm not talking about all 3 of them. I'm talking about just 1 oxygen atom. How many electrons did it gain? Oxygen is in group 6. It needs 2 electrons to fill its octet. So it's going to gain 2 electrons from each aluminum atom. So first of all, it's in group 6. So it must have 6 outermost electrons. So I'm going to first draw the 6 dots representing the electrons of oxygen. Then after drawing the 6 dots, I'm gonna, and by the way, in these brackets I'm just representing one atom, okay? These two are gonna multiply them by 2. So this 2 is actually equivalent to drawing 2 aluminum atoms or aluminum ions over here, okay? But we don't do that. We follow the standard and we just write down the numbers in front. And then over here we're going to place 2 crosses representing the electrons that each oxygen atom gained from each aluminum atom or aluminum ion. Okay, so this is going to be 2 negative because oxygen gained 2 electrons. So now if you balance the charges, the total electrons lost by 2 aluminums are 6 electrons because each aluminum loses 3 electrons, and the total electrons gained by each oxygen atoms is 2, right? So the total number of electrons gained by all oxygen atoms, all 3 of them, is also going to be 6, right? Because each one is gaining 2 electrons, so the 3 would gain 6 electrons. 2 times 3 is 6. Okay, so this is the how you're going to represent the dot cross diagram of Al2O3. Let's do one more example before we end. Let's take magnesium oxide now. Magnesium oxide, MgO. Okay, magnesium has a charge of +2 and oxygen has a charge of -2. Reason? Because magnesium is in group 2. It has 2 outermost electrons, it will lose both of them, and oxygen is in group 6, so it's going to gain both the electrons that magnesium has lost. So this is how you're going to draw it. This is magnesium. It will of course have its 8 electrons. After losing the 2 electrons, place your charge, and then oxygen, just simply draw it out. This is your oxygen. It had the 6 electrons of its own and the 2 electrons it gained from magnesium. Okay, so this is how you're gonna draw it out, the dot cross diagram of magnesium oxide. And by the way, guys, remember the use of magnesium oxide. Magnesium oxide is used to line furnaces, okay? Line furnaces. Lining of furnaces, meaning it is used as a refractory material. In refractory, bricks are actually made up of magnesium oxide to line furnaces due to its high, very high melting point. Okay, around 2000 degrees Celsius. So since the melting point is very high, therefore a lot of heat would be needed to melt it down. So if it is used to line furnaces in which the temperature actually is very high, so it's not gonna melt easily, and so the bricks would be able to withstand the heat of the furnaces. But anyways, you don't need to write down the entire story. This usually comes for 2 marks. So this is the reason that since its melting point is very high, due to the giant ionic lattice, okay, due to the giant ionic lattice, because that's the key term that the examiners want you to write. Due to the giant ionic lattice, the melting point is very high, and if the melting point is very high, therefore it is used to line furnaces. That's the complete answer, and this pretty much sums it up. Try out drawing out the structure of Li2O and calcium oxide on your own, and this brings us to the conclusion of this class. In the next lecture, we are gonna move on to covalent bonding. That's it. Thank you.